Hello everyone. In this experiment, I am going to create two different type of network using Cisco Packet Tracer. The first one is client-server network and the second one is peer-to-peer network. After creating both networks, I will test their connectivity and compare based on five criteria: architecture, resource management, scalability, security, and cost. I will start with the client-server network. First, I open the Cisco Packet Tracer. I'm currently on an empty workspace where I can create my network topology. First, I need a switch. I'm going to network devices section and at the bottom left of the Packet Tracer window. Then I'm selecting the switches from the available switches. I'm selecting the 2960 switch, especially the 2960 24TT model. I'm dragging it into the workspace. I will use this switch as central connecting devices for the connect network. I can see that the device is named switch 0. Uh, Next, I need the client computers. I'm going to the end devices section. From here, I'm selecting PCPT. I'm dragging the first PC into the workspace. Packet Tracer automatically named this computer PC zeros. The PC will act as one of the client in the client server network. I'm adding the PCs in the same way. This computer is automatically named PC1. PC1 will be also act as a computer. Next, I'm adding the PC2 and adding the PC3 and PC4. And I need a dedicated server because this client server network, I'm going back to the end devices section. I'm selecting server PT and dragging it into a workspace. Packet Tracer names it server 0. Server 0 will provide services to the client computers. Now I need to connect all devices. I'm selecting a connection option represented by the lighting symbol. From the available cables, I'm selecting copper straight through. First, I will connect PC0 to switch 0. I'm clicking PC0. Here, the packet tracer shows several ports such as RS232, USB 0, USB 1, and fast Ethernet 0. I'm selecting fast Ethernet 0 because this is Ethernet network interface of the PCs. Next, I'm clicking the switches 0. I'm selecting fast Ethernet 01. So PC 0 is now connected to the switch 0 through the port FA01. Now I will connect Now I will connect PC1. I select copper straight through again. I click PC1 and select fast Ethernet 0. Then I click switch 0 and select fast Ethernet 0 by 2. Therefore, PC1 is connected to the switch 0 through port FA02. The process is repeating for PC2, PC3 and the server also. Now my client server topology is completed. I have four clients PC0, PC1, PC2 and PC3. All four PCs are connected to the switch 0. The dedicated server 0 is also connected to the switch 0. The switch provides connectivity between the clients and the server. The basic structure is PC0, PC1, PC2 and PC3 communicate through switch 0 and switch 0 provides connectivity to server 0. This is called a client server network because server 0 is dedicated to providing services to the clients. Now, an important step, that is configure the server 0. Now I need to configure the IP address of server 0. I'm opening the server 0. I'm going to the desktop tab. Then I'm selecting the IP configuration. I'm entering the IPv4 address. 192.168.1.10. The subnet mark is 255.255.255.0. I'm leaving the default gateway empty because all the devices are in the same local network and I am not using a router in this experiment. Now the same way we have to configure the PCs also. Now I will configure the PC0. I'm opening the PC0 and selecting the desktop followed by the IP configuration. And at the form I'm assigning the IP address that is 192.168.1.11 and the subnet mark same as we configured for the server. Again, the default gateway is left blank. Similarly, we doing this process for all the PCs. Now all the devices have unique IP addresses. The server is 190.168.1.10. PC0 is 192.168.1.11. PC1 is 192.168.1.12 and so on. All devices use the same subnet mask, that is 255.255.255.0. Therefore they belongs to the same local network. Now we have to test the connectivity using ping command. Now I will test the connectivity between PC0 and the server 0. I'm opening PC0. I'm going to the desktop and opening the command prompt. I will use the ping command. I'm entering ping 1.2.168.1.10. This send the packets from PC0 to server 0. As I can see, I'm receiving replies from 192.168.1.10, that is our server. Therefore, PC0 can successfully communicate with the server. Now, enabling the HTTP services. Server 0 services HTTP. Now, I will demonstrate an actual service provided by the server. I am opening the server 0. I am going to the service tab. Here, I can see different services. I am selecting HTTP. I am making sure that HTTP is turned on. This means server is now acting as web server. The access server from PC0. Now I will access this server from PC0. I'm opening PC0. I'm selecting the desktop. Then I'm opening web browser. In URL field, I'm entering http://192.168.1.10. I will click go. The web page is displayed successfully. This provides that PC0 is acting as a client and server 0 is providing the web service. Therefore, the client server network has been successfully implemented. Now, I will create the second network, which is peer-to-peer network. I will create this in a new packet tracer file so that the two topologies remain separate. I am selecting the file new. First, I need to switch. I'm going to network devices and selecting switches. I'm choosing the 296024TT switch and placing it in the workspace. This is switch 0. Now I'm going to the end devices. I'm selecting PCPT and placing 4 PCs in the workspace. The computers are PC0, PC1, PC2 and PC3. This time I am not adding a dedicated server. This is the main difference from the previous network. I'm selecting a copper straight through. I will connect PC0 Ethernet 0 to switch 0 fast Ethernet 01. Then PC1 fast Ethernet 02 switch 0 fast Ethernet 02 as PC2 fast Ethernet 02 switch 0 fast Ethernet 03, same as PC3 also. Now all four computers are connected to the switch. This network does not have a dedicated server. Instead, the computers are peers. Each computer can communicate with other computers and can share resources with them. Therefore, this is a peer-to-peer network. Now, I will configure the IP of PC0. I'm opening PC0. I'm selecting the desktop and IP configuration. I'm entering IP address 192.168.2.11. Subnet mask is 255.255.255.0. This default gateway is left blank. Similarly, we are configuring all three PCs. Now I will test communication between the peers. I'm opening PC0. I'm going to the desktop and opening command prompt. I will enter ping 192.168.2.12. This sends packets from PC0 to PC1. I'm receiving replies from which means PC0 and PC1 can communicate successfully. I can also test PC2 and PC3 by using their respective IP addresses. Therefore, the peer-to-peer network functionally correctly. Now, I will compare with client server and peer-to-peer network. First is architecture. The client server network uses a centralized architecture. There is a dedicated server that provides services to the multiple client computers. The peer-to-peer network uses a decentralized architecture. There is no dedicated server. And the second one is resource management. In client server model, resources and services can be centrally managed by the server. In peer-to-peer model, resources are distributed among the individual computers. Each peer can share its own resources. And the next one is scalability. Client server network are more scalable and suitable for large organizations because client and services can be centrally managed. Peer-to-peer networks are more suitable for small networks. As the number of peer increases, management become more difficult. And the fourth one is security. Client-server network generally provide better centralized security because user authentication and access control can be managed at the servers. In peer-to-peer networks, security is distributed among the individual computers, making centralized control more difficult. And the final part is cost. Client server network generally cost more because they require a dedicated server and administration. But peer-to-peer networks are less expensive because they do not require a dedicated server. To conclude, I have successfully created and tested both client server and peer-to-peer network using Cisco Packet Tracer. The client-server network uses a dedicated server and provides centralized management, better security, and better scalability, but it has a higher cost. The peer-to-peer network does not require a dedicated server. It is simple and inexpensive, but it provides less centralized management and it is more suitable for small networks. Therefore, client-server networks are generally preferred for large organizations, while peer-to-peer networks are suitable for small networks. This completes the experiment, and thank you for hearing me.